Welcome to Maths and Science by IITian channel. In this lecture, we will discuss about the orthogonal matrix and other types of matrices. In the last lecture, that is lecture number 2 of matrices and determinants, we have discussed about 12 types of matrices. Now, we will take this forward and we will discuss about more types of matrices. We will define more types of matrices. And once you know about the types of matrices, then operations on the matrices will be easier for you to understand. Now, what type of operations? Operations will be addition, subtraction, multiplication, etc. And this lecture will be very useful for JEE and Maths Olympiad. And in this, we will be taking up orthogonal matrices and other types of matrices also. And especially when orthogonal matrices are concerned, the inverse of a matrix is equal to transpose of a matrix. Then it is called as orthogonal matrix. It's nothing but Q transpose is equal to unit matrix. This way also you can prove define what is the orthogonal matrix. Now, let us dwell into the subject. Let us take a matrix Q is equal to 2, 3, 4, 6, which we have been taking 2 by 2 matrix from the beginning, and we have to define what is transpose. Transpose is interchanging of the columns to rows and rows to columns. Interchange of rows to columns and columns to rows. Now, if Q is this, what is Qt? 2, 3 will become the first row, will become the first column, and second row will become the 4, 6 will become the second column. This is the transpose. This is first row, this is the second row. First row will become the first column. This is the first column. This is the second column. Rows and columns interchange. Then transpose of a matrix is formed. Now, what about the inverse? Inverse we have told you already. From characteristic equation, that is the best way of finding the inverse. But before finding the inverse, whether this particular matrix is orthogonal or not, how to find out? Question is whether above matrix is orthogonal or not. How to find out? Q is there with you. Q and Qt, transpose of Q, product of that should give you, what is that? Unit matrix. For orthogonality, QQT is equal to unit vector. Now let us see Q and Qt. QQT, product. QQT is equal to 2, 3, 4, 6 into 2, 4, 3, 6. Here, whenever you multiply two matrices, the first row will get multiplied with the first column. First element is equal to product first element is equal to first row elements, respective elements into first column respective elements of second matrix. This is of first matrix. Please understand this. For example, similarly for other 2, 3, 4, 6 into 2, 4, 3, 6. How it can be done? The first element will be, these will be multiplied with these first row elements and added. Two into 2. This will be 2 into 2 plus 3 into 3. First element. Second element is second row into first row into second column. That is 2 into 4 plus 3 into 6. Then this is the first row is over. First row elements we have multiplied with the respective elements of first column and second column of the second matrix. This is P, this is Q. Let us say, then what happens? This second row should be multiplied with the first column. That is 4 into 2 plus 6 into 3. Then second row will be multiplied with second column. That is 4 into 4 plus 6 into 6. That is equal to 2 into 2 is 4. 4 plus 9 is 13. 2 into 4 is 8. 8 plus 18 is 26. 4 into 2, 8. 8 plus 18 is 26. 4 into 4, 16. 16 plus 32 is 36 is equal to 52. That is equal to 13 into 1, 2, 2, 4. Thirteen is a scalar, I have taken it out. 13 into 1 is 13, 13 into 2 is 26, 13 into 2 is 26, 13 into 4 is 52. This is not equal to I. Hence, 2, 3, 4, 6 is not an orthogonal. Answer is 2, 3, 4, 6 is not orthogonal matrix. This is how we have to find out whether something is orthogonal matrix or not. Now, tell me, what is the determinant of orthogonal matrix? Orthogonal matrix determinant is, please remember this, determinant of orthogonal matrix, because orthogonal matrix into transpose of orthogonal matrix is equal to unit matrix. Determinant of an orthogonal matrix is equal to plus or minus 1. It's also very, very important point to be remembered. That you please cross check. I will give one orthogonal matrix example. Let us check whether it is an orthogonal matrix or not. A matrix A cos theta minus sin theta, I told you it can have any value, element can be complex number also. Sin theta and cos theta. If A is this, then what will be the value of A transpose? Here we have to check orthogonality of this matrix, whether it is orthogonal or not. A is equal to cos theta minus sin theta cos theta. Then what is AT transpose? This first column becomes first row, that is cos theta sin theta, and second column becomes second row minus sin theta cos theta. Then let us find A into AT, that is equal to cos theta minus sin theta cos theta into cos theta sin theta minus sin theta cos theta. This is equal to cos theta is cos square theta, first element, plus sin square theta, that is minus into minus is plus, and second column in the first row cos theta into sin theta sin theta, minus into plus is minus sin theta cos theta. Then second row and first column sin theta cos theta minus cos theta sin theta, and second row and second column sin square theta plus cos square theta. This is equal to AAT is equal to cos square theta plus sin square theta is 1. Cos theta minus sin theta, cos theta plus sin theta, it goes to 0, and this goes to 0, and this will be 0, and this will be 0. This sin square theta plus cos square theta is equal to 1. This is I. It implies it's a unit matrix. It implies A is equal to cos theta minus sin theta cos theta is orthogonal matrix. This is an example of an orthogonal matrix. Now I will give an homework to you. Give 3 more examples of orthogonal matrices. Even though it is not clearly told orthogonal matrix in IIT JEE Advanced 2025, there is a question is given on the same concept. It's a very important concept. Please try to remember this. There is a question given on the same type of concept in JEE Advanced, and there can be this type of questions in JEE Mains also. We cannot ignore. And what is the determinant of orthogonal matrix? Is plus or minus 1. Now we will find out the determinant of determinant of A, that is equal to determinant of cos theta minus sin theta, cos theta, that is equal to cos theta into cos theta is cos square theta, minus of minus sin theta is minus plus sin square theta, that is equal to plus 1. Determinant is equal to 1. That means this is also another important concept for orthogonal matrix. Determinant is equal to plus or minus 1. Now as a homework, you give me an example for which determinant is equal to 0. Example, provide, it is homework, A such that it is orthogonal and its determinant is equal to minus 1. And this is how orthogonality of a matrix is found out. There are some more matrices are there and another important thing, if there are two vectors or two matrices, both are column matrices, multiplication of matrix can be done when number of columns in the first A, number of columns is equal to in B number of rows. If it is not so, then you cannot multiply. For example, a single column matrix, matrix, we should not put the comma, 1, 2, 3 is one matrix A. It can be row matrix, or it can be a vector, and B is equal to 4, 5, 6. How this matrix is written? First matrix, it is written as 1 by 3. 1 row and 3 columns. This matrix can be written as 3 rows and 1 column. You just see, number of columns in the first matrix is equal to number of rows in the second matrix. Number of columns in the first matrix is equal to number of rows in the second matrix. Then only we will be able to multiply. That means AB is equal to 1, 2, 3. It is an introduction about multiplication operation. No, second is 4, 5, 6. Then it will be 1 into 4 plus 2 into 5 plus 3 into 6. This is equal to 4 plus 10, 14, 14 plus 18, 32. And it's a scalar quantity. That means if two vectors are there, one vector A is represented by a row matrix and another vector B is represented by a column matrix, and the number of rows in A or number of columns in A is equal to number of rows in B, then multiplication is possible, then A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. And if both are column matrix, there can be both are column matrix. It is a column matrix and B is also column matrix. Then A dot B cannot be possible because both are column matrix. The number of columns in the row matrix should be equal to number of rows in the column matrix, but both are column matrix. Then we have to transpose this one. A transpose dot B should be equal to A dot B. These are all concepts, because until and unless you make the transpose, you cannot multiply two vectors, two matrices. I will stop here. Now, in the next, we will go for matrices with complex numbers. Matrices with complex numbers. Complex numbers. Matrices with complex numbers we will be dealing. In that, we will be talking about the Hermitian matrices and then unitary matrices. Hermitian and unitary matrices. Skew Hermitian also we can talk about unitary matrices and skew matrices. With that, we will be completing the types of matrices. Then we will take up the problems in the types of matrices. Afterwards, we will go into the operation of matrices. Here, types of matrices will be completed. After that, we will go for operator. Before going to operators like addition, subtraction and multiplication, we will go for examples and questions from JEE Advanced, JEE Mains and Maths Olympiad on determinants and matrices. Definitions. Then we will go for the operators, then again we will go for the questions. This is how we will complete our matrices syllabus and determinant syllabus, and then we will go for simultaneous equations. If there is a value addition to your knowledge because of this video, please subscribe to my channel Maths and Science by IITian. Share and subscribe. And if you feel we are little bit slipping out of the syllabus, you can stop here. But however, I will give a lecture on complex and Hermitian and unitary matrices. If you don't want that, then you can skip that. If you feel there is a what you call, I can rather say, more of the content. But however, I feel it is better to know different types of matrices before going for the real matrix operations. Share and subscribe to my channel. And in this particular thing, it is not, because it's a matrix operation, you should not put dot or cross. We should not put vector also here. It's a matrix operation and it's a scalar product. That we can say. Not dot or cross, we can do like this. Matrix is a vector, we can put the vector sign also on the top, no problem. That means if A and B are two vectors, both are of column vectors, then A dot B, the dot product of A and B, those two column vectors will be A transpose B, A transpose into B, as we have seen in this example. Best of luck to everybody. Thank you for seeing my lecture.